So hello everyone, and we are very happy to have today talked about the Keycloak, and thank you for joining this presentation. This presentation consists of the two parts. The first part of this talk is about introducing to you the recent Keycloak update about security feature support. And the second half of this talk, we would like to introduce to you the Keycloak recent updates on observability and give some demonstration about that. So in the first of this talk, I would like to talk about the Keycloak recent update on security features. Before my talk, let me introduce myself to you briefly. My name is Takashi Norimatsu, and working for Hitachi Limited, Japan. And I am also the Keycloak maintainer. In this talk, I would like to introduce to you the two Keycloak special interest group, the community activity, Keycloak OAuth SIG and Keycloak Site Reliability Engineers SIG. The objective of OAuth SIG is to support OAuth, the OIDC, and its related security specification support to Keycloak to make Keycloak more secure, while the objective of SRE SIG is to improve the lives of the people like you running Keycloak and operating Keycloak. So each SIG has its own GitHub repository and also CNCF Slack channel. Therefore, if you are interested in the activity of those SIG, please access to the CNCF Slack channel. It's an appropriate place for you. So in the past of this talk I just mentioned before, I'd like to talk about the Keycloak recent security and future updates. And this slide shows the recent contributions by the community OAuth SIG. And the features marked with the test tube means that those features are treated as experimental or preview feature, not official feature. While the items marked with the checkbox means that those features are treated as officially supported feature. So the OAuth SIG not only do the contribution to the newly supporting security specification to Keycloak, but also do the contribution to define the Keycloak already supported security features. This slide shows an example of such the contribution for refinement. In this talk, I would like to pick up two security specifications that relatively the recent Keycloak supported. RFC 9449 OAuth 2 demonstrating proof of possession called DPOP, and OpenID for verifiable credential issuance called OID for VCI. The DPOP enables you to prevent the misuse of a stolen access token. As you might know, the OAuth 2 specification, RFC 6950, states that an access token is treated as bearer token, which means that everyone holding an access token can use this access token, for example, to access APIs. Therefore, if an attacker can steal an access token from the client application, then this attacker can use this access token to access APIs illegally. So in order to prevent such security features, the depop can be used. The depop enables us to make non-access token the sender constraining token, which means that only a legitimate client application can use non-access token. So therefore, if an attacker can steal an access token from the legitimate client application, then this attacker cannot use the access token to access APIs. The second feature is OID for VCI. Before introducing to you OID for VCI, I would like to tell you briefly the background of OID for VCI, and why OID for VCI specification was developed. As you might know, the EU citizen will be able to use EU digital identity wallet called EUDI wallet. This EUDI wallet can securely manage and store the data called verifiable credentials, VC. Roughly speaking, the VC is a digitalized version of some kind of certificate in the real world. For example, in national ID, the driver's license, passport, or the university degree certificate, and so on. So the major characteristic of the VC is that everyone can verify the authenticity and integrity of the VC. This entity called issuer or credential issuer issue this VC to wallet. So therefore, some communication protocol was needed to convey this VC from issuer to wallet. So the OpenID Foundation developed the OID for VCI specification as such a communication protocol. By following OID for VCI, the wallet can request some type of VC to the issuer, and the issuer can issue this VC and send back to the wallet. The Keycloak experimentally supported this OID for VCI, but only experimentally support. And it also covers only the part of the whole OID for VCI specification. And the Keycloak, the current OID for VCI support, plays the two roles: token issuer as authorization server and credential issuer as resource server. So therefore, the wallet firstly receives an access token from Keycloak as token issuer, and then the wallet requests VC with this access token to also Keycloak as credential issuer. So finally, I would like to briefly introduce to you the current OAuth 6 activity. The OAuth 6 are now trying to support the following new security specification support. For workload identity, the transaction token and SPIFFE, and OAuth 2 for first-party application called FIPA, and shared signal framework called SSF, defined by OpenID Foundation, and OpenID Federation, also defined by OpenID Foundation. And please note that those working items is not the Keycloak, the development teams, the working items, because the OAuth 6 is purely the community activities. Today, I'd like to pick up the specification, the FIPA and OpenID Federation. FIPA allows us to provide browserless OAuth 2 flow for native application. As you may know, by following the authorization code flow, or authorization code grant of OAuth 2. Then the end user need to input their credential for user authentication onto a browser. While by following the FIPA flow, an end user can input their credentials for user authentication to a native application, and no need to use the browser. So therefore, this FIPA flow is suitable for first-party native application use case. For example, I heard that some banks developed their own first-party native application for their end-user authentication. And they provide their end users with this first-party application. So therefore, in this case, the FIPA might be applicable. And the OpenID Federation enables us to build the trust between IDPs and RPs on the fly. No need to establish in advance. The OpenID Federation allows us to do the similar thing done by TLS or MTLS, but however on an application layer. And the promising use case for OpenID Federation is dynamic client registration. Please consider the situation that you run the Keycloak as IDP, and your Keycloak accepts dynamic client registration request from RPs or clients. But however, your Keycloak only want to accept the request from the legitimate and trustworthy client application or RPs. In this situation, the OpenID Federation can be used. The actual current adopters of OpenID Federation is Italy's digital identity system, the SPID. So that's all for the first part of this talk. Thank you very much. And I would like to pass the presentation on to the Ryan. He will describe the Keycloak recent update on observability and give some demonstration about that. Thank you very much for listening.
Thank you, Takashi. Can you hear me okay? Is the sound on? Yep, we're good. Okay. So, yep, my name's Ryan Emerson. I'm a principal software engineer at Red Hat, and I work as part of the Keycloak SRE team. Today, I'll just quickly go through some of the enhancements to our observability story we've made in the last 6 months to a year or so, and then hopefully we'll have a live demo that works. So the thing that we're particularly proud of is we've spent quite a bit of time improving our documentation. From the screenshot I've got here, you can see that we have, I think, 7 different guides. A lot of them are kind of operational in the nature, how to enable tracing, metrics. But the 2 guides that I would like to highlight here are the first one, which is our guide on Keycloak service level indicators. In this guide, we go through the concept of service level objectives and service level indicators. The take home, if you're not familiar with these concepts, is the SLO, the objective, is basically your target, and the service level indicators are your measurements to, what you can use to make sure you're meeting that objective and reaching that target. So in this guide, we go through and explain these concepts in a lot more detail than I just did, and we provide some example service level objectives that you might want to have with your Keycloak deployments. So I've just picked one here. This screenshot is of the table we provide, and it's a SLO related to latency, and we would say that we want 95% of all authentication related requests to be in the sub 250 millisecond range. Now, the indicator that you would use to ensure that objective is being met could be the response time for all HTTP requests as measured by the server. So then in this table, we then provide a couple of metrics that could be used as the foundation for that indicator. So then building upon this is the second guide that I want to highlight, which is our new in-depth guide on all of the metrics that Keycloak provides. Within this guide, we have many subcategories as listed on the left-hand screenshot here. Metrics relate to the core Keycloak functionality, JVM metrics, database, HTTP requests, as well as very in-depth metrics for clustering, whether that's a local cluster or clusters across availability zones if you have a more HA environment. But all of these guides have the same kind of format. On the screenshot on the right here, we have an example from the clustering guide, and we basically provide the raw metric names followed by a high-level description of what those metrics are and what it actually means, because raw metrics aren't very nice. But what I particularly like about these guides is that we have a bit of context around the metrics. So we have the light bulb here, and we're saying actually on a healthy cluster, the average replication time will be stable or with little variance. So you as a Keycloak user can read that, and then that can inform your Prometheus alerts. So if the response time does start to fluctuate, you page somebody, and hopefully they catch things before it's too late and the whole system goes down. Not like Keycloak ever goes down. So there's a lot of metrics covered in those guides, and metrics can be maybe a bit too much data focus sometimes. So we now provide Grafana dashboards out of the box from Keycloak 26.2. 26.2 will be available next week, all being well. The two dashboards we provide, one relates to troubleshooting, which I'll show shortly, and the other relates to capacity planning, which is basically to ensure that your cluster and your deployment is right-sized based upon a given amount of the current load that the deployment's satisfying. These dashboards are all available on the URL on the slide. You can use them as is, or you can use it as the foundation for some kind of customization. These are new, so please try them, raise GitHub issues, the usual community process. We would love to see what you think about them. So then next in our story is tracing. Tracing was introduced in Keycloak 26.0 as a preview. It's fully supported since 26.1, and we provide spans for all incoming and outgoing HTTP requests, including identity provider brokerage, as well as spans for outgoing database and LDAP calls. What's nice about this is that we expose it via the tracing provider SPI. We use this internally within all of Keycloak's providers, but if you have a Keycloak extension, you can leverage this, so you can create your own custom spans. And finally, the last thing is logging. A lot of people have asked for support for the Elastic Common Schema format. This is now supported by all log handlers. So we'll jump into the demo now. Hopefully my Minikube cluster is going to be doing its thing. The architecture is as follows. We have a local Minikube cluster. Within that, we have a single Keycloak pod, which is talking to a Postgres database. We're then using Prometheus to scrape the metrics. We're pushing our spans to Jaeger, and we're consuming logs via Promtail, which is storing things in Loki. We then have Grafana consuming all of this as our single pane of glass. So before I touched on service level objectives, I'm going to reuse the example from our documentation. In this deployment, we want 95% of all authentication-related requests to be faster than 250 milliseconds within a given 5-minute range. So I'll just jump to the browser here. We can see the Keycloak UI. I'll log in here. And for those who are already familiar with the UI, this might look slightly different. I am using the 26.2 nightly build. So I'm going to go in, and I'm going to select our realm, which is realm 0. Within this realm, I have created 100 users. And in the background, I have Gatling logging a user in and out every 1 second just to lightly load the system for the purpose of the demo. So now I'm going to jump to Grafana, and I'm going to refresh this. And we can see that we have this SLO metrics panel. It's saying that all of our pods are available, so that's good. And then we have this second graphic here, which is responses below 250 milliseconds. We're currently at 99.44. I was hoping that would be 100%, but never mind. On this panel as well, we can see that we have 0 error responses. So things are going well from an SLO perspective at the minute. I'm going to quickly just jump to my command line here and introduce some problems, because that's way more interesting. And then I'll just now go through the rest of our troubleshooting dashboard while we wait for some problems to propagate through our system. So I'll just minimize the SLO metrics. The next panel up relates to JVM metrics. We can see the different pods we have here, just one in this case. And then we have visualizations for the usual kind of things you'd be interested in: average memory usage, CPU usage, and garbage collection time, that kind of thing. Next up, we have a panel which relates to database metrics. This is, the utilization of the connection pool, available connections, that kind of thing. But for the purpose of this demo, the most interesting panel is this HTTP metrics. There's a whole bunch of visualizations here, but I'm going to focus on 2 today. One of them is the total number of requests per Keycloak URI and their outcome. So hopefully you can read the text in the audience there. But on the right-hand side here, we have a list of the different endpoints, and they're ordered based on the URI that's been hit the most. In this case, we can see that the 2 top ones are the auth and the authenticate endpoint, which we would expect, and then we're followed up by the usual readiness and liveness probes. So that's one panel that's quite nice and useful, so you can get a quick visualization on what URIs are actually being used on your system. But the next one that I really like is this heat map. So this heat map, we have request latencies grouped into buckets, so we can quickly have a sense of what requests are falling into what time ranges, and from the y-axis here, until the last few seconds, we can see that most requests were below 100 milliseconds. The delay that I've introduced has happened a bit too soon for me here. They were all meant to be below 100 milliseconds, but here we go. So what's really nice, though, is now that we have all of our tracing capabilities and everything that we've introduced recently, is we now have exemplars. So if I zoom out here and click on one of these, this pink dot is an exemplar. We can see the metric that it relates to, and we can see this is associated with the authenticate URI. So what's really nice here is we can click this query with Jaeger button, and we will get the full trace spans associated with that request. We can see from the graph here, or hopefully you can see in the audience, the total request time was 170 milliseconds. And as we go down and see kind of the subspans that are in the graph here, we can see that 78 milliseconds of this is actually from the Argon hashing. And then as we go down, we can see we have some database calls. This select one here. We're going to Postgres, so we can see some attributes around that request. We can see at the minute this request took 74 milliseconds, so we're within our SLO, things are going well. And as I scroll down here, we can see there's a bit more database activity. We have some commits, which were a lot faster again, so I'm not sure what happened with that select statement. But when I go on the select statement, because it's an exemplar, the really nice thing is we can also see the logs associated with the metric. If I click this button here, we have a couple of debug logs. I assure you they're not that interesting. I just enabled this to show the fact that we do link the logs. But that's how this kind of scenario looks when things are going well. What we can now do, though, is hopefully when I click back here, we're going to be massively failing our SLO. Yep, we are. Now only 56% of our requests are within the 250 millisecond range. So what I would do is, the idea is now I've seen what a normal trace looks like. I go back to the HTTP metrics. I'll go back to this same visualization, the heat map, and we can see there's a nice solid thick green number of requests here, with 24 requests that are almost at the second kind of range. So what exemplars allow us to do is I can now dive into this and hopefully figure out where the root of the issue lies. So again, same screen as before. The total request now in this case is 739 milliseconds. We go through the spans. We can see the argon hashing is in the same kind of ballpark as before, so I think it's safe to assume the issue's not there. But as we go down, we see this select statement has increased to 100 millisecond, and so is another database call, and actually the commits at the end in hundreds of milliseconds. So I'm sure you can guess where I'm going to go with this. This implies that the issue is with the database level, and there's some kind of problem between Keycloak and communicating with the database. So hopefully you'll agree that gives a very nice high-level, easy-to-consume way of figuring out the ballpark of where your problems lie. That's when the SRE engineers make their money. They go in and figure out what the actual problem is. But this is a nice head start and is much better than looking at logs, in my opinion. That's everything I wanted to show today in the demo. If you're interested, the root cause of the issue was I used Chaos Mesh just to add an arbitrary 100 millisecond delay to the Postgres service, which is why it was kind of uniform in the trace span there. But yeah, I think that was everything. So if you have any questions, feel free to ask them now, or I'll be hanging around after the talk, and so will Takashi. Thank you.
Okay, so sorry. As you might know, the KubeCon Japan will be held on this June in Japan, and there is the Keycloak maintenance track session. So therefore, if you will visit Japan to attend KubeCon Japan, I would be appreciated if you could join again the Keycloak maintenance session. Thank you very much.